Hello and welcome to week 2 of my game dev journey. Well, at least the recorded part of it anyway. So here's what we made over the week. It is that same spider we made for Halloween and rigged up and all that stuff, but this time he has feet that move properly. He can crawl over stuff wherever the heck he wants to, creep around like a little creepy crawly he is. Yeah, very nice. So for this video, I'll be kind of going over how I got to this point. It won't actually be a tutorial or anything, because it's all kind of experimental, unoptimized, etc, etc. And I'll probably gloss over a lot of things later on when things start to pick up. But for now, I'll just go over the more important bits, so at least there's an understanding on how I got to this point. So yeah, once again, unoptimized, disorganized. Not amazing, but it works, so that's all that matters. And hope you learned something from it. And hope it's useful to someone. And anyway, here we go. Okay, starting from the top. This is in Unreal Engine 5. This is a rigged skeletal mesh, and it is put on a control rig. And this control rig uses a plugin called Full Body IK. You have to enable it in the plugins. Very useful, very simple. All I had to do was put these controls on the control rig, of course, and it gives it inverse kinematics that updates its body position based on the leg position, which there's tutorials on that. I'll link the tutorial in the description. Very nice tutorials. And yeah, and so I got all these controls, simple stuff. Set the rotations of the feet so they match the ground, just right here. The rotation is 45 degrees right here. Very simple, very effective, very easy. Ignore all this. Which I'll probably make a more complicated rig in the future. But for now, this will do. Oh, and by the way, this is what my hierarchy looks like. All the controls are nested like so. They follow the root, etc, etc. So this is the control rig blueprint. It can hold variables and all that stuff, but I haven't really messed with that yet. So I have all of the variables inside the actor blueprint, which I do not recommend. All of these will probably be offloaded to an animation blueprint, so that's not cluttering up the actual actor, or into the control rig itself, because it can hold variables. But yeah, for now it's just stuffed all in here just for experimenting and prototyping and all that stuff. So, starting with the basics, the actual actor only moves using add actor local offset, very simple stuff. It has 2 variables per locomotion direction, which is forward and sideways for this one. The current velocity and the side velocity, you can put them into one vector if you want to. I just have them split up into 2 floats. It uses an F interpolate 2. This is the interpolate speed. And every time the input axis is put in, it goes 1 to -1. It's multiplied by max velocity. And that becomes the actual velocity target. And that updates the current velocity based on the interpolation. So that's just basically its update every time this is fired. So all that does is it translates the actor around based on that value in its local rotation. And it kind of just keeps adding that value as it interpolates. For example, if we went to lower that interpolation rate, which is right here, we'll say it goes 0.5 per update. That means it reaches that target velocity slower, so it ramps up a lot slower. And if you were to put it higher, it would go faster, of course. Alrighty, so the way the inverse kinematics actually works is it fires a line trace, but with a vertical offset from its default foot rest positions, which are stored as vector variables in local space, called base positions, right here. And that all that is stored right here, as in it grabs the actual control object in the control rig and sets the variables there. And the actual tracing happens here in this function per foot. And this is ordered in a way where it goes left, front, left, middle, left, back, and then on the right side. And that's per foot index. And per foot index, it chooses the base locations to choose from in each of the functions. And so it traces And when it traces, it has to determine if it's far enough away from the actual foot positions and does a comparison for all of them. And if it's outside this distance threshold, which is right here, 40 for this one, it decides that it should move its feet to compensate for the discrepancy. So it does that for all of them. If any single one of them are outside this threshold, it goes to this true-false thing. If it's false, it just maintains the foot positions in world space. It manipulates the control rig directly. I suggest putting it into an animation blueprint first, but this is, yeah, just directly for now. And also, the foot trace location is based on its velocity. Like when it's moving forward, it adds a base value to its trace location, so it's not dragging its feet around. Like it kind of predicts where it's putting its feet, so it maintains some consistency. And that value is added right here, based on its max velocity and its foot trace offset variable right here, which I have it to 50. And if it determines that any of the feet are outside this threshold, it prepares a couple of phase floats, which are used to actually determine at what point the leg is in its translation. It's the same thing for the actual actor interpolation, this f-interp 2. It's the same idea, except it's normalized 0 to 1. And the way it works is it starts out at 1, and it keeps decrementing the number by a certain amount till it reaches 0, and it has to reach 0 at a certain time. And that time is determined by how fast it's actually moving, determined by this foot max and foot min for these values. For example, if it's moving slowly, its feet have a higher base value for how long the feet take to move. And if it's moving fast, of course, it takes less time to move. And all of that happens right here. It uses this to determine how long it should keep its feet up in the air. And then it maps that range to the actual delta seconds, how long it actually takes for the last frame to happen. And then that decrements it from the actual phase value. And it takes that phase value, and this is what it does with it. In this function, it actually references a curve. And this curve is used to actually add different values to the vectors of the actual feet. For example, this is the curve for the vertical offset. From 0 to 1, this is what its feet do going up and down. And going horizontally, this is what it does. It interpolates to the value. And the values it interpolates from are the traces it just did in the other function, and of its feet position that it recorded from its last trace, or the base position if it started out right here. It also adds a vertical foot offset to keep its feet on the ground rather than protruding into the ground, because these base offsets are kind of based on the actual control locations rather than the feet locations. For example, here, how it's up on the wrist rather than the actual foot, so it has to add an offset so the feet are actually on the ground, which happens right here. I just put it to 5, which I'll zoom in so you can get an idea of all this stuff. And the way it phases its feet is, since it's spider-like, it has 6 legs, or more of an insect-like. It does 3 legs at a time, 2 on one side, 1 on the other. And it does that sequentially, like it moves one set and then the other. And in this case, it'll always update the other pair right after the other. So for this, what it does is it keeps decrementing the value until it reaches 0. And in this function, it determines whether it actually has reached 0. And then once it does that, it actually updates the foot positions of where it's actually keeping its feet in global space to where the trace is. So then it keeps that value, and then it moves on to the next set of legs until that reaches 0, and then it determines that phase is complete, and it goes back to index 0, which is determined here. So it knows that it should be tracing its feet again, or rather determining whether its feet are outside the distance threshold. So yeah, it's actually not that complicated. I mean, it looks terrible because it's just unorganized and all that stuff, but it's really not hard to understand. I mean, it's hard to put into words. I mean, like nodes, I mean. But yeah, it's just expressing how things work in a logical way. And all of this is just stuff I was trying to do to make its head move, which I'll put in a later date. So this is all just kind of nothing yet. We'll get there. Also, I'd like to make his arms move. And another thing, I'd like him to climb walls. Like, right now this is only vertical offsets. So if he tries to climb a wall, it just doesn't work. So I'll make it added some more logic so it figures out that it has to crawl over things. Lifts its legs up in certain ways whenever it reaches certain egress. That'll be nice. That'll be fun. Anyways, that's that. Hope you learned something from it. I don't know if you do. It's kind of disorganized. For now, still just experimental. It will get better. So, moving on. I was planning on putting the model we made last week into Twinmotion and making a render out of that, but I'm trying to focus on, I guess, the game dev aspect first, so we'll maybe do that later on sometime when we start focusing on the rendering. So for this week, I actually wanted to work on something for the game, like directly, for a change. So I made some concept art for some buildings, or a building. This will be the central hub for base building. Place it down, it's basically a power well. And also here's a thing I made a little while ago. Some basic base building. Hardly worth mentioning. Very simple. Just placing stuff around. But just for some context of what I'm trying to go for. So yeah. Anyway, onto the modeling. Let me know if I should separate the game dev and the modeling from each other, because it is kind of long to put them both in the same video. So yeah, let me know. Feel free to ask questions too, because I probably gloss over a lot of things, like what plugins I'm using, etc., etc. And anyway, hope you enjoy.